Today I want to show you how to multiply numbers. It's a new technique, and it's a technique that's extremely fast on a computer. It's also very easy to understand, and I think this is the way in which we should teach children to multiply. Also think, because of the efficiencies, this is how computers in future will multiply numbers. So there's 4 parts to this video. First, I'm going to review the schoolbook method. Then I'll show you 1 and 2 examples of my technique, and lastly I'll show you how to do it on a computer. Let's begin. First, I'm going to multiply these 2 numbers using the schoolbook technique. Schoolbook technique is taught throughout the world. There are other techniques as well, but the schoolbook technique takes the top number and multiplies it with each of these digits in turn. So I start with the top number multiplied by 1. That's very easy. I can just write the number down. Then I put a 0 here, and I multiply it with the next number, the digit 9 in this case. 5 times 9 is 45, and I have a carry of 4. 4 times 9 is 36, and 4 is 40. And I proceed in this fashion until I get to the final answer. A couple of zeros, and then I'm now multiplying with the 8. Few more zeros. Now with a 7. And finally I multiply with a 6. So after I'm done, I have 5 products. Each of those being the product of the top number with one of these digits. I add them all up to get the final answer. 5 plus all the zeros is 5, 4 and 5 is 9, and 3, and I proceed in this fashion until I get the final answer. That is the schoolbook method. Now I want to show you my technique. Now this technique works because whenever I multiply 2 single digits numbers, I get at most a 2-digit number. Likewise, if I multiply 2 5-digit numbers, for example, at most I get a 10-digit answer. Now this technique works by first writing out the 2 numbers like that, and it's important to know that each of these blocks occupy 2 digits worth of space. I spread it out a bit because I'm going to multiply these numbers with the ones below them, and I need 2 digits for each of those answers. So below those numbers I construct this pyramid, and you can see each block in this pyramid has space for 2 numbers. I do it neatly so that it's easier later on when I need to add all the numbers up, and proceed to create the pyramid like this. And once I'm done, I can start by filling it in. The top or the base of the pyramid is easy. I just multiply these numbers with one another. 5 times 1 is 5. 4 times 9 is 36. You can see how I write it out so that the digits are in the right spaces. 3 times 8 is 24. 2 times 7 14, and 1 times 6 is 6. Right? When I go to the next level in the pyramid, I spread out the numbers that I multiplied. Previously I multiplied those. Now I spread it out by 1, and I will multiply that pair of numbers with this pair of numbers. So here I have 4 times 1 plus 9 times 5, and that is 49. Then I move on. This block is in the middle of those 2 numbers, pairs of numbers, and I have 3 times 9 plus 4 times 8, which is 59. I proceed in that fashion. This time this block is in the middle of 2 times 8 plus 3 times 7, so the answer in here is 37. Go to this one. 1 times 7 plus 2 times 6, and I have 19. Then when I go to the next level in the pyramid, the space increases. This one is in the middle of those two pairs of numbers, 5 times 8 plus 3 times 1. And now I have a space or one set of numbers that I skip. That's my space. I go to the next block and I have 2 times 9 plus 4 times 7, which is 46. Go to the next one, 1 times 8 plus 3 times 6, and that is 26. Now I'm almost done. At this level, the numbers are spread even further apart, and I take 2 times 1 plus 5 times 7, which is 37. I move on, but I retain my space and I have 1 times 9 plus 4 times 6, which is 33. And I come to the top of the pyramid. At this level, I multiply the outer pairs of numbers. This is also exactly in the middle of those two numbers, and I have 5 times 6 plus 1 times 1, which is 31. There's my pyramid. All I have to do now is add up all these numbers with carry to get to the final answer. I'm going to create these little guides to help me with that, so that I keep the digits apart and so that I just add up one digit at a time. Okay, so using those guides, I can proceed and say, there I just have a 5, here I just have a 9. In this block I have 6 times 4, 6 plus 4, which is 10, plus 3 is 13. There's my carry of 1. 1 plus 3 is 4, and 9 is 13, and 4 is 17, and 7 is 24. I have a carry of 2, 2 and 4 is 6, 5 is 11, 17, 21. 2 and 2 is 4, 11, 15, 18, 21 again. 2 and 4 is 6, 9, 15, 18. Now sometimes the carry would be more than one digit. I just add it as a normal carry to the next column. 1 and 1 is 2 is 11, and 2, 13, and then 6 and 1 is 7, and the carry is 8. And there's the answer. Next, I want to show you how to use this technique if the two numbers have an unequal amount of digits. So here I have a big 8-digit number multiplied with also a big but a lot fewer 4-digit number. This time I proceed exactly as before in creating my pyramid, but the pyramid is not balanced. There's a lot of times when I don't create blocks because these numbers are all basically 0. I'll start again. 8 times 5 is 40, 7 times 6 is 42, and so on, to prepare the base of the pyramid. But as you can see, the base only extends as far as the smallest number. On top of that, I create the next level. Here, 7 times 5 plus 8 times 6 gives me 83. And for the next level, I would take 8 times 7 plus 5 times 6, 86. The next level would be 5 times 5 plus 8 times 8 gives me 89. And then when I get to this level, I start to multiply with 0. So I have 4 times 5 is 20 plus 8 times 0, and I only have 20 in that block. Likewise, the next block is 3 times 6. The next block is 2 times 7, and finally I get 1 times 8. All of these numbers are multiplied with 0, so I just need to do the 1 multiplication. The next block, likewise, I get 3 times 5 is 15, and 8 times 0, I don't even bother with that. 2 times 6 is 12, and 1 times 7 is 7, and I'm out of digits. Go to the next level. Here I have 2 times 5 is 10, and 1 times 6 is 6, and finally at the top of the pyramid I only have 1 times 5. 8 times 0 I don't even bother with. Add it all up and I get to the final answer. Now, this is why I believe this is a good method to teach children, because it shows you exactly which digits combine with which digits in the final answer. I can see that that digit is determined by all of these digits, which in turn will be determined by all of the digits in the two numbers. But this digit, the first digit of my answer, is determined only by the two least significant digits in the two numbers that I multiply. So it helps me understand how multiplication works, how it combines numbers to get to a final answer, and also the position or the significance in the answer that these cross products will occupy. Okay, now I want to show you how to use this technique on a computer. When you multiply numbers, especially if they are big on a computer, you often would use Karatsuba's technique. Let's say I have two large numbers, a and b. I can write down the digits of those numbers in this fashion. A0, the least significant one, a1, and so on, up to the most significant digit. That would be the same as writing it as this sum, a0 plus a1s, where s is a scaling factor. If I'm working with decimal numbers, the scaling factor would be 10. And all of these digits would be less than 10. So let's say I want to multiply these two numbers. I can write that multiplication down as a0 plus a1s times b0 plus b1s. That's just a different way to write a and b. And if I multiply that out, I get this answer, a0 b0 plus a0 times b1 plus a1 times b0 s, all of that multiplied by s, plus a1 b1 s squared. So for decimals that would be 100, for example. Now what Karatsuba discovered in 1960 is that this middle term, I can write it out as follows. a0 b1 plus a1 b0 is equal to a0 plus a1 multiplied by b0 plus b1 minus a0 b0 minus a1 times b1. And note that if I'm calculating this product, I've just reduced the multiplication by 1. Previously, I had to multiply 1, 2, 3, 4 times. 4 large numbers that I had to multiply with one another. But now, note that those two products are already available, and these two multiplications have been reduced into just one multiplication. Previously, I had to multiply a0 with b1 and a1 with b0. Now I multiply this sum with this sum, just one multiplication. But also note that this does not have to be 0 and 1, nor does it have to be consecutive indices. I can generalize this and say that ai times bj plus aj times bi is equal to ai plus aj multiplied with bi plus bj minus ai bi minus aj bj. So I can generalize Karatsuba's trick in this fashion. This is important. Let's apply that technique of mine to two 4-digit numbers. a0, a1, a2, a3. You will see this time the least significant digit is on the left-hand side. And that's very nice because this allows me to write down the answer from left to right, or sequentially. If I multiply two huge numbers, I can write the answer down from left to right, from least to most significant digit. As before, I construct the base of the pyramid by filling in the products of the digits in there. So they have a0, b0, a1, b1, a2, b2, a3, b3. And then in this block, or at this level, these three blocks, I put in these sums. a0 times b1 plus b0 times a1. Here we have it. Go to the next one, that's a1 b2 plus a2 b1. This block becomes a2 b3 plus a3 b2, and so on. This block I need to increase the space. A0 B2 plus A2 B0, and this one becomes A1 B3 plus A3 B1, and so on. And I have the whole pyramid. Now, this is just used as a way to index the multiplication that I will perform on my two numbers. If I want to write down the answer from left to right, I start there. If you want, that's my guide, and all the digits that, or all the blocks that align with that guide, I need to calculate. So I calculate this product and I write down the least significant digit of that and into the first digit of my answer space. Now, if I'm multiplying using computers, these might be 4-digit or 4-byte numbers, and the first byte becomes available after I've multiplied those two numbers. Now, because of carry, I need to multiply using words, or not even words will be enough. Because of the carry, I need double words or something like that. However, I don't need to allocate any interim space. I know, because I've got two 4-byte numbers, that the most amount of bytes, the maximum amount of bytes that I need for my answer will be 8 bytes. So I can allocate 8 bytes at the outset and store the first one there as soon as that product is available. When I proceed to the next one, I use this guide, I add my carry, and I add this product, and the least significant byte becomes the next byte in the answer. I proceed to the next column, or the next digit, or the next byte if I'm using computers, and I proceed in this fashion. Now note that these need not be single digits. They need not be bytes. A0 can be a megabyte, for example. It could be a really big number. B0 also likewise is a big number. Just using a suitable scale, this method will work even if these represent multiple digits or multiple bytes. Also note that this trick of Karatsuba I can apply in any one of these blocks. All of these blocks qualify for usage of this trick if, however, I calculate the base and store that beforehand. So if you do it like that, then I need some extra space, because before I start I need to calculate these products, calculate this base, because I use that repeatedly when I apply Karatsuba, and I can apply Karatsuba's trick in all of these blocks. Note that as I traverse this pyramid, I can do it in a number of ways. If I want to apply Karatsuba's trick in these blocks, I need to first prepare the base, or I can cache these numbers and go through the pyramid diagonally, dropping down the least significant digit in the answer. You can see there I have A0, B0. In this diagonal, A1, B1 is used repeatedly. Here, A2, B2 is used repeatedly. Or I can go through it in this fashion, reading A0 and B0, and then A1 and B1 gets put into the cache, then A2 and B2, and so on. So there's a number of ways in which I can traverse, and this pyramid really is a way in which I can index these large numbers when I multiply them. I've done some tests. The fastest method I found is to multiply from left to right. Don't prepare the base, just prepare the space for the final answer, and that is less than 10. It's even less than 5% the time it took the schoolbook method to multiply the same size numbers. The next best method is the diagonal one, but it's really fast, it's really efficient. The performance gain relative to the schoolbook method is huge. For numbers in the range of about 150 digits, it was best, and the performance was less than 5% that of the schoolbook method. If you want more information about this technique, go to this page, www.feathersolutions.com/multiply. There's a paper there that explains the technique in more detail. You can also send me a mail at multiply@feathersolutions.com. I'd love to hear from you, and get some feedback on this technique and some feedback on the paper. And yes, I hope it can help you to multiply numbers faster.